Hey guys, last week I published a video reviewing and doing some capacity testing on this RoyPow 105 amp hour lithium iron phosphate battery. In my test, the battery was about 2.5 amp hours off of the rated capacity. I didn't necessarily think this was a problem at all really, but it did raise some questions from some of my viewers as to why that was, specifically if the cells in this battery are properly balanced. Now the manufacturer did reach out to me and told me that I should have seen the full 105 amp hour rated capacity of this battery in my tests. So they recommended charging up the battery until the overcharge protection kicked in, and then discharging until the undervoltage protection kicked in. And that's exactly what we did, though they had suggested using a 0.5 C discharge rate instead of the 0.19 C discharge rate that we had used. So in today's video, we're going to test this battery again, but we are going to connect up a cell level voltage monitor so we can see exactly what's going on with the cells inside this battery, because I want to know why it did not test as advertised when it should have. Alright, so I've got the lid removed from this battery here, and on the set of balance leads that come into this BMS protection board here, I spliced on a new connector. So we can plug this into our balance charger and see what the voltage is of each individual cell within this battery pack. And I've just got this small ISDT battery go balancer that I'm going to be using for this purpose. So I can go ahead and plug the leads in the side here. Alright, so now we're at approximately 28 millivolts of difference between the high and the low cell of this battery. Alright, so here I have my iCharger X6 connected. We have it configured for 3.65 volts per cell. So we're going to go ahead and begin the charge cycle. Okay. So you can see as it's charging, the low and high cell are getting further and further apart. We're at 42 millivolts currently. And the iCharge is putting in approximately 8.25 amps. So it's a fairly low charge rate. So cell number 2 is definitely higher than the rest of these cells. We're at 86 millivolt difference. Alright, so now what's happened is the overcharge protection has kicked in and shut off this battery from charging when cell number 2 hit 3.65 volts. And we're sitting around 89 millivolts of difference between the high and the low cell. I don't see how this battery is ever going to balance, because what happens is the BMS in this battery is shutting this down right at 3.65 volts, which is the maximum charge for this battery. And because this is lithium iron phosphate, these voltages do not sit at full charge. You can see they're already dropping. So this battery never really has a chance to balance, because as soon as it hits the voltage at which most BMSs start balancing, it shuts off. Now to be clear, I don't know what the logic is on the BMS of this board in this battery. Now I highly doubt this battery has an active BMS inside, but maybe it does, maybe it's got some other kind of balancing logic. Alright, so now what I've done here is I've plugged in the balance lead directly into the iCharger X6. And I configured this such that the maximum charge voltage is 3.64 volts. So I'm going to try to charge this at a very low 1 amp rate and hope this iCharger will balance it out before the BMS in this battery shuts it down. So we're going to go down to Start. And you can see down here is the difference between the high and the low cell sitting at 38 millivolts. So look how close together these voltages are now that this charger is attempting to balance these out. We're at a 1 millivolt difference while charging at 1 amp. That is pretty good. So we're just going to leave this run and see if it balances out at the top end, and then we'll redo our discharge test once this has completed. Alright, so I stepped away for a minute here and I got output connection broken. And it looks like we had put in 0.19 amp hours. So let's try this again. But the voltages are a lot more balanced. Let's just try this. Oh. So this BMS does still have this battery shut off. You can see we're reading 14.3 on the balance port, but we're at 13.8 on the output terminal. This output still has not turned back on. Let's see if I can get it turned back on by starting a discharge. Nope. Okay, so there it turned back on. You saw it jump up to 14 volts. So let's stop the discharge, plug this back in. So we're going to go back to the charge mode here again. Oh, it's still shut off. It shut the charge back off again. This is kind of frustrating. Alright, there we go. So now we are going to go into charge mode and do half an amp this time. Put this on slow balance and start. So I want to note exactly what voltage this shuts off at. So we can see it's balancing again. The difference is 13 millivolts and it's dropping fairly quickly. Alright, so it's shut off at 3.605 volts. Now those cells are very well balanced currently, if you see here. We're at 3.605 and 3.606. So if this battery is intended to be charged to 14.60 volts, I don't understand how, if this disconnected at 14.42 volts and these cells were all within 1 millivolt of difference. Alright, so now what I've done is I've taken the negative output from this charger and I've connected it directly to the battery on the inside, bypassing the built-in BMS of this battery. So what we're going to do is try to balance it my way here using this iCharger X6. And start. Alright. So now we should be able to take this all the way up to the proper 3.65 volts per cell and let it balance out the way it's intended. So we can see now we've reached 3.65 volts on some cells, so the charging rate is throttling back to 0.4 amps as it balances this battery out. Actually, it's not even doing much balancing because the cells are already near balanced. And we can see that only resulted in a difference of 0.04 amp hours being put in, so maybe that's negligible. But we can see our voltage difference between high and low cell is still at 3 millivolts, which is very healthy. Alright, so I've got the same exact setup here as before. We've got the battery, our display, the shunt for current, circuit breaker, and the inverter. So the plan is going to be to run the same incandescent light bulbs again, which should put us around a 0.19 or 0.2 C load. And then I'm also going to plug in the cell level monitor so we can keep an eye at the end of charge where all four of the cells stand, what the cutoff voltage is, and what the deviation is between the high and the lowest cell. Alright, so there we go. It's at 19.5 amp load. We'll be back when this finishes to take a look at the results. Alright guys, so we're approaching the end of this test here. We're at 11.4 volts and we're at 98.8 amp hours. We're around 2.81 volts on the lowest cell, and we have a difference of 103 millivolts between the low and high cell. So it's looking like cell number 1 is going to be the weakest of the four. Alright, so we're approaching 2.50 volts with a spread of 143 millivolts. Alright, so cell number 1 has dropped below 2.5 and the BMS shut off pretty quickly. So that was pretty accurate at the low end, but we're seeing around 150 millivolts of difference. So I see the final metered capacity is 100.85 amp hours, and that's around the same, slightly lower than our first test. Alright guys, so it's really bothering me that I can't get the rated capacity on this battery, and when I think about it, many of the batteries I have tested in the past have been slightly below their rating. So I want to verify that the shunt I'm using is not the problem with these tests. This is the shunt from a Victron BMV700. Now you'll see I'm using some different cabling for this shunt, and this one's not even the correct color. This should be black, and that is because the ring terminals on my other wiring harness do not fit through the bolts on this shunt. These are some very large bolts here, and that's why I'm not using this shunt for my routine capacity tests to begin with. So that shunt reports back to this Victron energy meter here, and you can see it is zeroed out for 0.0 amp hours. So we're just going to turn on this inverter, we'll run this down the same way we did before, and then once we get to near empty, I will plug in the cell level display so we can see our cell level voltages as well. So looking at our Victron, we can see we're pulling 18.9 amps currently, 255 watts, and 0.1 amp hours so far. Alright, so our test is coming to a finish here. We're currently at 97.7 amp hours, and the lowest cell is number 1 at 2.62 volts, with a voltage differential of 137 millivolts. Alright, so that shut off right at 2.49 volts, and I didn't catch what was on the display because I was watching the video, but I do believe it was around 98.4 amp hours. Alright guys, so I've gone through every possible scenario I can think of as to why this did not test at 105 amp hours as it's rated. I even went as far as to testing a separate shunt, the Victron shunt, just to make sure that the Baytrium shunt I was using was reporting accurate data. One of the things I found while doing my testing is that the BMS is cutting out at 3.60 volts. It's supposed to be cutting out at 3.65 volts per the manufacturer's recommended charge voltage of 14.6 volts. Now I did use an iCharger to attempt to balance this battery and bring it up to 3.65 volts per cell, and that resulted in less than a half of an amp hour going in. Now that is completely to be expected because there is very little stored energy at the beginning and the end voltages of the charge cycle. And to add to that, I don't see any problem at all with this being programmed for 3.60 volts. That's just going to allow these cells to last a lot longer. But if that's the case and that was their intent, why not have the specifications indicate a charge voltage of 14.4 instead of 14.6? That is the confusing part to me. In the end, I don't see any reasons why this would not have hit 105 amp hours other than mismatched cells. A few people did point out the wire sizing I was using should have been a little bit thicker, but I'm only testing at 20 amps. In my first test I used number 6 wire, and in my second test I used number 4 or larger wire. In both cases, those wires are more than sufficient to handle 20 amps. Additionally, we are measuring current through the shunt. We're reporting amp hours. We are not reporting back watts or watt hours. So the resistance in the wires is negligible for an amp hour reading. Now the manufacturer did recommend that I test this at a 0.5 C rate, but I don't see any reason to believe that's going to give a greater capacity than the 0.19 C rate I did. If anything, it's going to give a slightly lower capacity. I don't think this is a bad battery. It's very well designed. It's just not 105 amp hours. It should be marketed as a 95 amp hour or a 100 amp hour or something to that effect. RoyPow was very generous and did give us a 15% discount code if you're interested in purchasing one of these from Amazon. I will leave that code in the description of this video along with a link to the battery. Thank you for watching, and please feel free to leave any questions or comments you may have.